All right. All right, Grant. So we're seeing your screen right now on your Slack channel.
Yeah, I should probably, especially private conversations,
We're all
with
good,
you.
man. We're all good. So, hey, thanks everybody for coming out to Lancaster AI here for June of 2020. And I'm really excited to be able to introduce Grant today. Grant's going to be talking a little bit about deep speech, the Mozilla framework for NLP. And I'm excited to hear all the things that you've worked on and what you got going on here. So I'm going to hand it over to you, Grant, and go ahead.
Okay, so I haven't really done any coding for this. Really, it's basically been using a lot of the built-in frameworks and just looking at what are the possibilities that we could possibly use in with this framework. Um, so just a little bit of background. This is the documentation, deepspeech.readthedocs.io. Um, you can, its other main website is just, it's basically GitHub repo. I don't really want to go, but so the first thing that we need to do, so there's several, how do I put this? So there are several different ways you can use it. You can use it as, actually they built their own client that you can use. It's really, so you could actually go ahead and maybe like set up a bash script and just send your files up for like loading up all the text. We'll look into that. We'll look into uh, an example code where it will take in my microphone and be able to do automatic, basically normal dictation. There's a lot of issues with that package, but the code is all there. It's in one of their examples, which is a little bit like, do I have to? Also, we're going to, also I pulled up tmux, so we can actually, so one nice thing about tmux is I can set up multiple things and then I can just htop into it. So I'm using almost 3 gigs of RAM, but you get to see basically how my computer performance while I'm actually running these programs. Hopefully Zoom won't affect the performance very much because it does take a little bit for the algorithm to simply decode the 9-second audio transcription that I've had. So the easiest solution to getting everything set up, so here's the documentation, and there's really two main models that they have. The one is the big models.pb, which is like a byte file. It's the larger model that you might put onto a server. I've also looked online that it's also sometimes computationally more efficient. I'm not quite sure than TF Lights, but the TF Lite model, and you just get all this stuff from, yeah, their releases file or their releases. So you just go to github.com Mozilla/deepspeech. That's their GitHub, and then the releases. So this is the main one we'll look up is 0.7.4. Now the two models that you can have are both the here's the larger one that usually goes onto an actual server, and then this one we could actually use on a smaller device, like let's say a Raspberry Pi. If you've ever heard of TF Lite, you'd know that's usually what it ends up going on. So so let's go into, oh yeah, also I want to show you, if you scroll down, you'll get all these different ones. One thing is that not only is this have they built the code, but this is also a library that's built off of using the TensorFlow framework and can be used. So the models, I think I just downloaded this one, the pb.mm. The PB looks exactly the same size, so, and then the um and then of course if you look at the TF Lite, this is why it's built for distribution, 45 megabytes compared to 180 megabytes. So if you're tight on space, it's a really good place to go. And then you also need to get different packages. So, and then for the main applications that we use, we are going to be using the native clients, both AMD 64 CPUs, Linux, and then also there's also, I believe, the TensorFlow. There's also, where is it? Maybe it's up a bit. If I go into my project, or whoa, hey there, done. I need to get out. Okay, so if I do, so this is, so you look for the native client and for TF Lite. So so CPU, here it is. Okay, so these are so this one is the TF Lite one, and this one's the normal model. In the normal model, you just then also copy down the model, and you just put that file into the folder. Same with the TF Lite. So I've already done a bunch of the stuff. So if we go to the native client, also if I just also let's because I want to show you the audio of that. But dot, and then we just run. So as you can see, I've got the library or the model downloaded, and I've got this WAV file. So one of the major issues with the native client to play around with is that you can only give it the WAV files. It won't pick up your microphone. So the way we use this, you'll have to set deep speech up as an executable. And then we pass in the -- model. And okay. And then the audio as in dissolve bands. This is a 9-second clip, and if we just run it, should happen pretty quickly. At least that's, so yeah, here it is. So in the course of human events, if becomes, so it, of course, like there's some errors with this, and I've tried it, I think, before on later models in like the .9 branch of the releases, and it seemed to have actually worked a lot better. So and just to hear what the audio file is. Well, so were you guys able to hear that? Oh, it was me basically not really quoting. I don't think I actually quoted it accurately on the beginning of the Declaration of Independence. So so if you guys know it, in the course of human events, it becomes necessary for one people to dissolve the political bands that have connected them to another. Um, so that's really so we would probably run this for your on your server and just get like the main output. Um, and then we want to do the regular or the light one. So to show you what that looks like, instead of having that PB file, I have the TF Lite file. So if I just run -m, you always have to pass in your model. And then -a, and I think this one has a little bit less work with it. So yeah, uh, when I wasn't running Zoom, it was going a lot quicker. Like within like 5 seconds for a 9-second clip, it was going. And actually, let me run this again because I wasn't. So my CPU usage on only one of my threads is actually going up, really, or going up significantly. Um, so now, and then this is pretty much the last part I have that as an example. Or um, so I basically copied their. So I cloned an example repository, and it has a bunch of um, files, so or a bunch of examples, and what we're going to be looking at is this one. This will just be able to. This doesn't send it to a server. It's basically Python code. So, um, so I have a Python virtual environment set up. One thing I need to point out is it looks like it uses the tensor. The issue is that it uses, I think it uses, it needs to have the dash dash systems requirements for me. I think because I needed to install stuff through my package manager. So if you're having any trouble, especially on Linux, go ahead and definitely run, when you're setting up your virtual environment, set up the dash dash system something, system requirements, I think. And then just do a pip install -r requirements, and you'll should have everything. So let me activate this virtual environment. And okay, and then I just run and model, and then I just pass the model of it. So hopefully we can see a few problems. Yeah, the wake up call on this script isn't completely accurate, and it goes off. Here, hold on. There's a package. I'll get to that later. But we might be able to have this like send out like find out like maybe different sentences and then go through that. If it's just not that many sentences or that long, it can actually go ahead and figure it out. One thing I've seen, I'm not completely sure, but one thing I've seen is on the Raspberry Pi 4, it can actually go ahead and do this in real time. So we don't need this like huge infrastructure. And as you can see on my CPU usage, it's not even really going up when it's doing it. So, yeah. Um, so the next thing I just want to point out is that you don't even need to use Python for this. It's you can install it as a library, and you can do it as a C API, .NET even, Java, JavaScript, and of course Python. And these have all the APIs and even shows you possibly how to use them. So for you'll like load up the model, and then you might, and then if we actually open up the file, you could basically read down how the client could work in that language. So I think it pretty much goes into so also the model architecture, just to look into how large any model could be. The main model is, I believe, 3 layers of each 2048 LSTM like lengths, parameters, I guess. So, and I think and I believe LSTMs use 3 per node. So you have, but if you think about it, that's actually pretty small compared to like some GANs and other stuff. So, I guess we go into questions, Rich, or?
Yeah, let's do it. You ready? You ready to take some questions?
Sure. Let's see how how prepared I was.
All right. Well, anybody's free to ask questions. I do have a question that I want to kick it off with, Grant. So, how is the performance? Because what I'm seeing, the performance running it live, and it doesn't seem like it's picking up a lot of the words and it's able to transcribe them in real time. But have you tried this in other areas, like, or in other installations, and seen what kind of results you could get out of here? Like, how reliable are we talking this library is?
So it's hard to say. Well, for first, I've done it. Interestingly, I'm wondering, Zoom is actually using up quite a bit of my CPU usage. So I think
Mm-hmm.
a lot of my problems are with performance is actually Zoom itself. It just uses up. I haven't installed CUDA onto my computer, and I have an NVIDIA GPU on this laptop. So that could very well be that Zoom is just consuming so much. And then without Zoom, it's very much real time. That 9-second audio clip uh, of me speaking, it ended up going within like 5 seconds, maybe less. So we're a little bit we're a little bit quicker than real time. And my CPU also, this is another big thing. My CPU is my computer is from like 2017. So it is a Core i7, but it's a lot slower. Now on the other hand, I have seen like videos of basically people hooking up Pi 3s and Pi 4s. I don't have a Pi 4. I didn't have the time to get one and hook everything up, and hopefully it would work. To see if I could get it to work on a Pi 4 in real time also. So that's the main issue there.
So, could we look at your TMUX that you have set up with the microphone app running?
Or just this is
Yeah, that
just,
one.
it's
Yeah.
just a
So
terminal.
yeah, so when you had the terminal set up there and you're running the microphone, the microphone app, it seems that that one didn't work as the other model, which was the one where you fed it a pre-made wave file. That one seemed to work really well versus the real-time microphone. But you
Yeah,
think the real-time microphone was related to the performance?
I think one thing I'm not entirely sure, but one thing is that I tried this when I wasn't on Zoom and I was trying it. It was
Mm-hmm.
as if the first word or the first couple words were never detected. So I'm wondering if there's a like delay there of
Mm-hmm.
like realizing, oh hey, there's something that I need to catch. So
Mm-hmm.
maybe an example is that the microphone is always recording. And then once it catches it, it goes back a little bit and then it transcribes.
Mm-hmm. Mm-hmm.
So
Interesting.
also a lot of these examples are very much community driven. So it's not like it, even though it's hosted on a Mozilla GitHub page, it's a completely different repository. Um, I think I forgot to show it, but yeah, it's completely different. Even though Mozilla is hosting it like deep speech, they're not even showing. Uh, they're not having it in the same repo. And of course, there's other different things. So you could get Android, some Node.js on as like the Node.js is on a server. I haven't seen it through a web browser, which could be very interesting.
Cool. Any other questions out there?
No, but Grant, thanks for doing this. I enjoyed it. I probably am not up to the level to understand totally, but I see the application. And job well done. Thank you.
Awesome. Well, thank you, Grant. That was a fantastic presentation. I appreciate it. That was a nice dive into deep speech and kind of getting it up and running and all the different things that we can do with it. And so I'm going to stop the recording right now. We can hang on afterwards and we can talk. Did you have a comment out there?
No.
No.
Just
Mm-hmm.
Well, the main thing is just there's a bunch of examples. The only real issue I have is the documentation is like almost like scattered brain. That's the main thing, but the cool thing is that there's different APIs and there's examples on how we might be able to implement it.
Very cool.
So.
All right. Well, thank you, everybody. I'm going to stop the recording now. And for anybody else watching in the future, we hope to see you at a Lancaster AI channel. You can always find us at YouTube at Lancaster AI. You can also find us at lancasterai.com. And we look forward to seeing you again next month. See you, everybody.